We're going to head into example 2, and again, we're going to set it up. I'm probably not even going to use this part. We're just going to set it up the way we did on the previous problem and use reduced row echelon form. And so let's take a look at what's going on. We have x plus y plus z is equal to 36. We need to make sure these are all in standard form, and I see that they are not in standard form. I also notice that we're missing some variables, and we're going to have placeholders for that when we write our matrix equation. So we have 1, 1, 1. Well, actually, let's not get ahead of myself here. X plus y plus z is equal to 36. And so now we have an x. We have an x. We need to move this 0.5y over to the other side. So I'm going to subtract 0.5 from both sides. So 0.5, whoops, let's make a 0.5. Let's make that a little clearer. So we're subtracting 0.5y from both sides. There is no z value, and I'm lining these up over here intentionally so that when I write my matrix equation, it's easy to see what variables I'm missing. If I move this 0.5y to the other side and get this negative 0.5y, that becomes 0. And then for our third equation, we are missing an x value again, but we have a negative y and a plus z, and this is equal to 1. So when I write my equation, let's make this a little bit nicer. When I write my equation, actually, I don't want to use this, and it's kind of right in the middle of the page. So I'm going to write my matrix equation right here. And so we just bring down, remember, it's our coefficients, 1, 1, 1, 1, 1, 1. Jump down to, and we can bring our 36. We can draw our line right now and put 36. We could separate this out. I go to my next equation. I'm going to bring down the coefficient in front of my x, which is 1. This is negative 1/2, negative 0.5. There is no z variable. You must have a placeholder if we're missing that variable. So, and then it's equal to 0. We jump down to our next line. We have 0 for x, negative 1 for y, 1 for z, and 1 for our solution. We're going to do the same thing. We're going to bring up our calculator. And, oh, there's our last one, so nice work. Let's come up. We're going to get to our matrix. We want to edit it. And you could actually, like, if you wanted to, right, you could, let's see, what could we do? We could come over here, and then we could edit matrix B. I guess we could edit matrix B. I'm just going to go ahead and edit matrix A, just because it'll be easy. So let's do this. It's already a 3 by 4, and we can see this has 3 columns, or 3 rows, excuse me, 4 columns. So I'm just going to leave that the same, and then we're going to change. We're going to input our matrix numbers. And so I did that first row kind of fast. I just entered 1, 1, 1, 1, enter, 1, enter, 1, enter, and 36. When I get to my second row, I'm going to be a little more careful because we've got our 1. So we hit enter. And this is negative 0.5, so negative 0.5, enter. 0, again, we have to have that placeholder. I can't stress that enough. And then this is equal to 0. And then on our final row, we have 0 for x, negative 1 for y, 1 for z, and 1 for the solution. And I want to check all these numbers again, just to make sure that I haven't made an entry error, because that can be that's a pretty common error, right? So it looks like my solution matrix is good. My z column is good. Remember, this is like our x column, y column, z column. When we set this guy up, so it looks like my z column is good. We have 1, negative 0.5, negative 1. That also looks okay. So let's see, 1, 1, 0. That looks okay. So we'll find out here in a second. We need to get back to our home screen. So we double checked our numbers. We need to get back to our home screen. So I'm going to go second mode to quit. And then we need to tell the matrix what we want it to do. Now, the cheat code for this is I could just scroll up and hit enter because I'm using the same matrix. That's pretty nice. And if I do that, it'll pop up. But let's go ahead and go through all the steps again just so you can do it one more time. And so we're going to go second. We need to get back to the matrix. We need to go over to math because we want to tell it what we want it to do. We're going to scroll down to reduced row echelon form, option B. If you do option A, REF, that will give you the wrong answer. So we hit enter. And again, now we need to tell it what matrix we want to find the reduced row echelon form of. So we go second matrix. And we're already on matrix A, so I don't have to do anything. We hit enter. I hit enter, and it looks like our solution is 7, 14, and 15. So 7, 14, and 15. So it looks like X is 7, Y is 14, and Z is 5, excuse me. Wait a minute. 15. Yes, 7, 14, and 15. So we are okay. The next, and instead of like doing anything else, like we're not going to pause, we're going to roll right into this. We have systems of 3 equations. So we have to write some equations, and we have to define variables, write equations, and we're going to rewrite your equation using matrices. We don't have to solve. You guys can solve if you want. We don't have to. In fact, no, maybe you need to solve. So Vista Ridge High School is ordering more technology equipment. Laptops cost $715, tablets cost $410, and cell phones cost $245. Must not be great cell phones. So they purchase 25 times more tablets and cell phones. That is an equation. Probably don't like it, but it's an equation. So the district spends a total of $250,350 on 486 devices. That is another, that's not equations, but those are totals that we're going to need to write some equations. So it says, how many of each device did they purchase? So our variables have to be the devices, right? So I would set this up as L is the number of laptops. You could do X, Y, and Z, it doesn't matter. I like the variables to make sense in the context of the problems. Cell phones is going to be C, that's the number of cell phones. And tablets, I kind of did this out of order, is going to be T, that's the number of tablets. So I know that we know the total number of devices, right? So if L, C, and T are the number of the devices, we would say that L plus T plus C is equal to 486. And those are our devices. Now, so that's our first equation. That one's pretty straightforward. The second equation, I'm going to use my total of $250,350. And so that means I'm relating the cost, the total cost, to the number of each item and the cost of each item. So here's what that's going to look like. We know that laptops cost $715, so 715 L, plus each tablet cost 410, 410 T, plus each cell phone costs $245, and that's equal to $250,350. So that equation was a little more challenging, but like always, our last equation is going to be the most difficult. It says they purchased 25 times more tablets than cell phones. My equation for this is T equals 25C. So however many cell phones they purchased, we're multiplying that by 25, and that gives us the number of tablets. And if you need to think about that, think about if they purchased, just reading from this, they purchased 25 times more tablets than cell phones. If I ordered one cell phone, we'd have 25 tablets. So if C was 1, that means that tablets is 25. And so that's how we're going to set that up. I'm not going to rewrite it using these matrices. I'm going to, well, actually, let's rewrite it using this matrix, because you'll need to see this on the test. You don't have to solve this one. If you do solve it, I would use my technique and use your reduced row echelon form. So first off, we're just bringing down our coefficients in front of L, T, and C. So 1, 1, 1. And then we're doing the same thing on the next line. So this is going to be 7, 1, 5, 4, 1, 10, 2, 4, 5. And then we need to be careful. That's not in standard form. So I need to move my 25C over. I'm going to subtract 25C from both sides. And so we're going to get, there's no L, there are no laptops on this thing. So we get T minus 25C is equal to 0. And so for my T value for this one is 0. And then we've got, let's see, what do we have? We have 1T, we have negative 25C. And this is going to be the number of laptops, the number of tablets, and the number of cell phones. And so just kind of think about how we arrange these. We did L, T, and C, and then we're just taking this and kind of turning it sideways. So that's our coefficient matrix, our variable matrix. We have our solution matrix, which would be 486, and this would be 250, 350. And this is going to be 0. All right. Let's solve this. We don't necessarily need to rewrite this whole thing at this point. Hopefully we know enough that we know we're just going to kind of join these two together at this point. And maybe I should just rewrite it just so we have it. If we're going to put this in our calculator and use my reduced row echelon form, remember it's going to be my coefficient matrix. So we're going to write it as our coefficient matrix and our solution matrix. And we're going to kind of jam them up together, right? So we get, I'm going to use this space right here, we get 1, 1, 1, 4, and we're going to need more room than this because those big numbers. Let's go 1, 1, 1, 486, and then we have 715, 410, and 245, and this is equal to 250,350, and then we have 0, 1, negative 25, and 0. Oops, that was kind of gross. Okay, let's double check my numbers. 111, 250, 350. Yeah, that looks okay. So let's put it in our calculator. Let's grab our calculators. And here's what we're going to do. We're going to go second. We need to get back to the matrix. And we need to edit these numbers out. So this is going to be, again, this is a 3 rows by 4 columns. So 3 by 4. And it looks like, well, we're kind of already set up 1, 1, 1, 1. And then 486. We have to overwrite 3 to 36. So 486. And then we're at 715, enter, 410, enter, 245, enter, and now it's our big number, 250, 350, enter. So, oh, we already have a 0 for my x. So y, or not my x, but my L, t is 1, and c is negative 25, and this is equal to 0. Let's check our numbers again. So this looks like it's probably okay. 1715. All right, let's quit. So we need to get to this home screen. We need to tell it what we want it to do. So we're going to scroll down to A. I think we can probably go up, maybe get there a little easier. Reduced row echelon form. We hit enter. And, oh, dang it, that is not what I wanted. Do you guys see what I did? I didn't quit and get home. So we're going to quit. And now we want to go back to that matrix. So we have our reduced row echelon form once we quit out. And we need to tell it what matrix we want to do it to. So we're going to go matrix. We only have A programmed in, so we hit enter. And there we go. It looks like we have 174 laptops, 300 tablets, and 12 cell phones. So let's write it as LTC, and this is 7. Whoops. I'm looking at the wrong thing. 174, 300, and 12. So 174 laptops, 300 tablets, and 12 cell phones were super cheap. And so this is the solution to this system of linear equations. All right, so today we're going to solve systems of 3 equations using matrices. And so kind of what we've done so far, we've done what I call 2 by 2, 2 equations, 2 unknowns. We've done that by hand. We've done that as inequalities and equations, right? So we've also done, last time we've done 3 by 3, and you guys like realized how fun that can be, how frustrating, seriously. It can be pretty tough if you make a tiny error, things go wrong. Well, we can do this 2 by 2, 3 by 3. There's no upper limit to the number of equations and the number of variables, right? We could do a 10 by 10, but that would be awful by hand. And so if we go on in math, we learn another technique, and it's called matrices. And so if you are going to go on, we'll learn how to do this by hand. But we are going to use our technology, we're going to use our calculators to do this today. And so this will be pretty nice. So if you don't have a calculator, I need you to pause the video and get a calculator. Okay, so we're going to find the solutions to a system of 3 linear equations. This would work if it was 4 linear equations, 5 linear equations, 50 linear equations. Our calculator probably couldn't do it because it doesn't have the processing power, but other things can. Your computer could, all kinds of stuff. So if we have a system of 3 linear equations, and this only works if the equations are linear, so straight lines, doesn't work for quadratics, x squares, or anything like that. So here's what's going on. We're going to do a little rewriting of this thing, and we're going to do it a little bit differently than these notes say, because the way I do it is easier than the way the notes do it. So we're going to kind of skip this, and we're going to do something different. We're going to talk about it. Don't worry about this part right here. I don't care about that. So we're going to take, like look at example 1, we're going to take our system of equations, and we need to do some work to it. We need to rewrite it so that we can use our calculator to get an answer. And so the first thing we need to do is we need to make sure each linear equation is in standard form. It seems like we do that a lot, right? Put things in standard form. It must be kind of important. And then so A, B, C, and D are just numbers. And so A, B, and C are coefficients of the variables. And so we're going to take those coefficients and we're going to put them into a 3 by 3 matrix. And so this 3 by 3 matrix, all that talks about, all this really means, when we talk about matrix, this is the dimension of the matrix, and sometimes you'll see it referred to as DIM. But the dimensions of a matrix, we always calculate or figure out the dimensions of a matrix the same way. And so we're reading our rows times the columns. Row times column, or rows times columns, doesn't matter. So here's what we're going to do. We're going to come over and like look right here. So this is our coefficient matrix. Whoops. So that's our coefficient matrix. That's a 3 by 3. So we're going to take those coefficients and we're just going to write them right here. Only the coefficients, right? So we have 3, -4, 2, 1, there's a 1 in front of that x, 5, -3, 5, 2, and 3. If I was missing, like say I didn't have this 2z right here, then instead of a 2, I would put a 0 right there. So you have to have that placeholder. So that's our coefficient matrix. And then we're going to take the variables, and we're going to write them in a 3 by 1 matrix. So this is our coefficient. And it's a 3 by 3. This is going to be our variable. And it's going to be a 3 by 1. And we're just taking our variables in the same order as they appear in our equation, right? Because the variables aren't always going to be x, y, and z. They could be other things. So we want to make sure that it's in the same order. X goes first. And then we bring down our y. And then our z. And so that's our variable matrix. The last thing that we have over here is what's called our solution matrix. and that is also going to be a 3 by 1 matrix. And so our solution is just whatever this thing is equal to. So we're going to bring those numbers down. I'm going to bring down 18, negative 15, and 20. So we've set this whole thing up. And then from there, we should probably write this up here. We're going to place the solutions. And so this would be matrix D down here into a 3 by 1 matrix. And then we're going to not do this. And we are not going to do that. So here's what we need to do. There's the way the notes tell us to put this in our calculator are kind of long and involved, and they're not easy to figure out. And so what we need to do is we're going to shortcut this, and I know a better way. So here's what we're going to do. I'm going to use this space right here. We have to rewrite our matrices. And so what we're going to do is we're going to take our coefficient matrix. So I'm going to take my coefficient matrix 3, negative 4, 2, 1, 5, negative 3, 5, 2, 3, and we're going to put a little bracket right there. Instead of a bracket on the other side, we're going to put a straight line. And so this is our coefficient matrix. And then we're going to write our solution matrix right here. We're going to write 18, negative 15, 20, and we're going to close that off. And so this would be our solution, right? Solution matrix. Now when we look at the dimensions of this combined matrix, this is 3 rows and 3 rows and 4 columns. So it's a 3 by 4. So we're going to grab our calculator and we're going to do a little work. To put this in your calculator, and the notes that you have right here are good, like this first step. Step 1, step 1, A through G, we're going to do all that. We are going to do this part differently. So part 2 is going to be different directions. So you can try and do this part 2 or not, but I have a much easier way to do this than doing all this business. So let's jump back up here. Okay. So let's grab our calculators. Here we go. So first off, we need to get to the matrix feature, which is this blue key right here. It says matrix. So we're going to go second. And this is the X inverse button, but we want to access the matrix. We need to edit our matrix, so we're going to scroll over and we're going to hit enter. From there, notice it says 1 times 1 or 1 by 1. This tells me that we have a 1 by 1 matrix, so I need to change this to a 3 by 4. I just hit 3, enter, 4. I hit enter, and notice my matrix is very different. And I'm going to enter this matrix over here. So we're going to enter 3, enter negative 4, enter 2, enter 18, 1, 5, negative 3, negative 15, 5, 2, 3. It is always a great idea once we enter these numbers into our calculator to double check them. So it looks like we have 18, negative 15, 20, 2, negative 3, 3, 4, 5, 2. Let's scroll over this way a little bit. 4, negative 4, 5, 2, 3, 1, 5. Okay, so we've double checked. We need to input our values in the matrix. If we didn't have like this 2z right here, that would have been a 0 instead of a 2. You have to have a placeholder for this to work. You can't leave one of these blank. Your calculator will give you an error. And so we need to get to our home screen, so we're going to go second mode to quit. And now here's where you're going to have to start writing some things down. Our directions are going to be different than they were on that sheet. And you can write them here, you can go down and write them on that sheet, it doesn't matter. We need to get back into our matrix operations here, so I'm going to go second matrix. And I want to go over to math. And so we're going to scroll down and scroll down and scroll down. That's kind of weird. And we're looking for RREF. And so what this stands for is reduced row echelon form. Right above it, notice it says REF. That is not what we want. If you do REF, you'll get the wrong answer and you'll never know. So we are looking for a reduced row echelon form, and that is option B. So we're going to hit enter. We're getting the calculator ready. We're telling it what we want it to do, and we want it to find the reduced row echelon form. We hit enter. Now we could program all kinds of matrices in here, so we have to tell it what matrix we want it to do perform this operation on. So we go second, matrix. The only matrix we have programmed in is matrix A, so we're going to hit enter. You can close the parenthesis at that point or not, it doesn't matter. So we've told it what we want it to do, and we've told it what matrix we want it to perform the operation on. We have to hit enter and it'll do it. So we hit enter, and I want you to notice one thing. And it's kind of good, we have our equations over here, right? It looks like my x value is 1, so the coefficient on x is 1, and this is a 2. Now there's, on our second equation, our second row here, there's no x value, but it looks like we have a 1 for y, so that's a coefficient in front of y, and this is equal to -1. And then on our third row, we have a coefficient of 0 and a 0 for my x and my y. My z is 1, and this is 4. The way that we have set this up, what this has done is this tells me that x is 2, y is -1, and z is 4. So we're going to write that right here. So this is 2, -1, and 4. These are, so now this, with my variable matrix, is the solution to this system of equations. 2, -1, and 4, the solution to our system of equations.